Good afternoon, everyone. How did your homework go? So, any questions about the homework? 7-11. Okay. All right. So we look at number 7. And it's 7 part E. All right. So number 7 part E. So we have the function f of w equal 2w squared plus 2w plus 11. Okay, and the question is what? Sorry, find the zeros. Okay, so the question is find the zeros. The zeros of f. Okay, and so finding the zeros means basically we set the function equals 0 and we solve for x. So we're going to set f of w equals 0 and solve for w. And then I will kind of elaborate this graphically. So we're going to have 2w squared plus 11 equal to 0. All right, so we're going to set this up. So when I set it up, usually the first thing we ask ourselves, can we factor? Can we just look at it and factor? Means can I find two numbers? When you multiply them by each other, you get 11. You add them to, this is impossible in those cases. So we're going to try the quadratic equation. So we're going to use the quadratic. Okay. So how does the quadratic is? So we have to first, my A is it 2 here, my B is it 2, and my C is 11. And the quadratic involve what we called last time the discriminant. We're going to compute this quantity. So I first computed by itself, which is equal to B squared. It means it's a 4 minus 4 times A times C, which is equal to 4 minus 4 times 2, that's 8. 8 times that, this is minus 88. So it's going to give me minus 84. Okay, that's an interesting problem. So I compute B squared minus 4AC and I get a negative number. What does this tell me in this case? What does really this tell me? So if I use the formula now, what's going to happen if I use the formula? The quadratic formula tells me that W supposedly have two solutions, supposedly, and I use supposedly here. It should be minus the B plus the square root, so we have 1, of minus 84 divided by 2A. But what can you say? Quickly. Any comments?
You can't square a negative number.
Exactly. The square root of minus 84 does not exist because we cannot have a number. When you square it, you get a positive number. So this can't occur because we can't have the square root of a negative number. We can't have the square root of a negative number.
So will we just have to put that it's undefined?
No, you put that there are no zeros. The student asked the question, it means there are no zeros. So it means that F has no zeros. What does it mean? It means there is no value of W which make the equation equal to 0. No value of W that make f of W equal to 0. Okay, and let me a little bit talk about the graph. What's happening graphically so you will understand the picture. Graphically, that's what's happening. F of W is quadratic. That's f of W. Okay, it's a quadratic function. The A is positive, it means that it's a parabola going up. There are no zeros, it means there is no value of x where the function is equal to 0. We don't have that. It means the way the function is going to look like, it's going to look like this. That's how the graph would look like. And we know how to find the vertex, so we can take care of that in another problem. But graphically, that's what's happening. This is the parabola, but this parabola never touches the x-axis. So there are no values of x which make this equal to 0. So that's what's happening graphically. That's why it's not surprising for the function not to have zeros, because a parabola can look like this. There is no x's such that the f of w equal to 0, or no w, sorry, in this case, where f of w equal to 0. Okay, so the answer would be f of w has no zeros. There is no value of w that make the function equal to 0. All right? Amber, it makes sense? All right. Okay, so any other question? I'm trying to understand. 7E, we did 7E. Amber is asking about number 8, DE. Okay, number 8. Okay, I will look at it. So we have typical quadratic function, which is x squared minus the 6x plus 5. Okay, so that's my function. And okay. And the question is about D, E, and H. Now I cannot do D without doing basically part A, and you will see in a minute. So first we're gonna do part A, or okay, A is simple. The question is, A is what is f of 3? Sorry, f of 2. Okay, f of 2, it means you just plug in 2 into the equation. There is nothing. 2 squared minus 6 times 2 plus 5. So that's simple. That's 4 minus 12 plus 5, which is minus 8 plus 5, minus 8 plus 5, which is minus 3. Okay, that's f of 2. And I know the question is D, but I can't answer D without B. I have to answer B. What are the coordinates of the vertex? Okay. Now I gave you the formula for the coordinate. The x coordinate is minus b over 2a. That's the x coordinate. And in my problem, the a is a 1, the b is minus 6, and the c is equal to 5. Okay, so the x coordinate is minus 6 over 2, which is equal to 3. That's the x coordinate of the vertex. So the y coordinate is the value of the function at 3. It means that's my function. The value at 3 is 3 squared minus 6 times 3 plus 5. It means 9 minus 18 plus 5. 9 minus 18 minus 9 plus 5, which give me the minus 4. All right, so the vertex, the coordinate of the vertex is 3 and minus 4. All right. So now I can graph, because that's what the question is. Without this, we can graph the function. So let's graph it. All right, two things. First, A in this function is 1, which is positive. So it's a parabola concave up. So that's the shape. Okay. Now I know the vertex. The vertex is 1, 2, 3, and minus 4. 1, 2, 3, minus 4. My vertex is right here. Okay, I'm getting ready. Now, as I always told you, as I told you last time, I always like to know when the function, when the graph hit the vertical axis. So I'll write the function here in front of us, because always everything guide me in this problem. Okay, if x is 0, the output is 5. Means somewhere the function will have to hit that. Okay, so the graph is going to look something like this. gonna go down. I don't know the zeros, so if I knew them, I will have a better graph. And that's the graph of my function. That's the vertex. That's the vertical intercept. It means when the graph, it means the output when the input is 0. And those are the zeros, so which are not hard to find. Very good. Now I can answer the question D. Once you graph, you can do that. On which interval is the function increasing? Now that I have the graph, when is the function increasing? Okay, so now increasing, it means when the input increase, the output increase. It's when the graph starts rising. Now I know this is 3. That's why I needed the vertex. So my function is increasing for x bigger than 3. All right, that's really when it is increasing. But I needed, as I said, B to be able to answer this question. That's why it's a D. And so this is increasing. So from here to here, we have it's increasing. And from up to here, the function is decreasing. So if it's decreasing, for x less than 3. So we know almost everything we want about the function. All right, the second question is E. E is what's the range of the function? The range are all the output value. What's the range of the function? Quickly on chat, tell me what's the range. We have a lot to talk about. What's the range? I don't like that. The range, all the output value. All the output value, not only -4, not only -4, all the output value.
-4 to infinity?
Exactly, -4 from here all the way to infinity. So the range, all the output value, it's -4 all the way to infinity. All the output value, not 1, not 2, every output value. So every input, every value here that comes from somewhere, these are the range. Now finally, I look at H. Okay, what is my H? H is, so H is find all the D's, all number D, such that f of D equal to 9. Right? So how should I do this problem? It means, what are they asking me here? Input or output value? Back to you. Are they asking me for input or output? Input. So they are asking me for all the input value. Sorry, I have to mute everybody. Okay, they're asking me for all the input value D such that f of D equal to 9. So the way we do that is that we set the function, which is becoming now D squared because they used the variable D, so I stick to the variable they used, minus 6D plus 5 equal to 9, and solve for D. Okay, all right. Let us recall how we solve that. The only way we solve this, that's a quadratic, is we make sure we make one side totally a 0. So I have to subtract 9. Okay, make this is equal to 0. That's always my first step, and this would give me D squared minus 6D plus 5 minus 9 minus 4 equal to 0. Okay, so need to solve this one. So that's a quadratic equation. Now how to solve it? Always we try to factor. And if you cannot, we use the quadratic. Now, if I want to factor, it means I'm looking for two numbers. You multiply them, you get a 2. Sorry, you get a 4. You add them, you get 6. And no way. If you take two numbers and you multiply them, you get minus 2, minus 4. You don't have, you only have 1 and minus 4. They don't give you 6. 2 and 2, they won't give you 6. So we don't know how to factor this, basically. So the way we're going to do it is we're going to use the quadratic equation. So use the quadratic equation. Okay, so to use the quadratic, I first identify my A, my B, and my C. My A is 1, my B is -6, and my C is -4. Now I need to compute B squared minus 4AC, because based on the problem we did before that, if this is negative, it means I cannot find anything that satisfies this equation. So we have to make sure that things are fine. So it's -6 squared minus 4 times -4. So this would give me 36 plus 16. So that's going to give me a 12. Will give me 52. So B squared minus 4AC is 52. So now I have two solutions. So I have 2, 1 and 2. The first is minus B plus the square root of that divided by 2A. And the second is minus B minus. So now let us substitute everything. I'll focus on the first one. That's going to give me minus. Now B is -6. Minus -6, which gives me a 6, plus the square root of 52 divided by 2. Okay. Now, let's see if I can simplify this a little bit. If I can't, I will just estimate it using a calculator. Now, 52, I can write it as probably 4 times 13. Am I right? 4 times 3, 12. Yeah, it's 4 times 13. So this would become 6 over 2. So I'm doing now the algebra, purely algebra. So that would give me 6 plus. Now, here it is. I'm going to write it right there. The square root of 4 times 13, and this is something I'm going to mention again today, you can break it. The square root of 4 times the square root of 13. So this could be broken, and this is going to give me 2 square root of 13 divided by 2. Okay, so I'm doing this problem with all the algebra required. Now, one more thing we can do is the following. So this is already very good. One more thing we can do is we can factor out 2 in the numerator. If I factor out the 2, okay, to get the 6, I should have a 3 here. And this is divided by 2. And now 2 and 2 will simplify, and I will be left with that. Okay, so that's one solution. Now the other solution, which is going to be, if I use my calculator just to have a picture in my mind, what this is going to be. So this is going to be plus the square root of 13. So this is almost 6.605. Okay, so that will be one value. The other value is minus b minus the square root over 2a. So that's the other one, which is going to be equal to, of course, we repeat the same thing, but whenever there is a plus here, we're putting a minus. So this is going to be 2 minus, 3 minus the square root of 13. Okay.
I have a question.
Please go ahead.
One, is this specifically going to be on our quiz today?
Oh, yeah.
Okay, and then do you want us to go like that in depth with it? Because I thought that we would like stop when you couldn't go anymore.
How far can you go? I forgot what the problem I gave you. Go as deep as you can.
Oh, sorry, like 7E.
Yeah.
We just
Go
Like-
as deep as you can. Okay? And I correct your algebra.
Okay,
Okay? So if you stop here, I will consider it correct.
okay.
Right? But I want you to keep going because it will help me to help you with your algebra. All right?
Okay.
Okay. All right. So finally, I will look at number 17. I'm going to look at that quickly and proceed. And I will assign another problem along 17 for next lecture because I want you to know how to do that. So number 17 is the following. Okay. So the height of an object above the ground, t seconds after it has been thrown upward, is given by the function, that's the rule, determined when the object hits the ground. All right, so what's the picture here? We take an object and we throw it. We take it and we throw it. All right, the object goes up and definitely it's going to go down. Okay, this function gives you the formula at every time t, what is the height for every time t. So that's really what this function tells you. So f of t tells you the height at every time t. So the picture, we have an object, we throw it up, the object go, at some point it's going to start going down. Okay, that's really the motion that's happening. And f of t, so we have a function, it's a rule. This tells you the height at every time, the height of the object. And I think the unit is, did I tell you unit? Okay, in feet, let us say. T seconds after we throw the object, after we threw the object upward. That's my function. That's really my output. So the input is time. The output is the height at this given time. And the formula for the height is given by, I follow the book, minus 16t squared plus 50t plus 200. Okay. So, for example, f of 1, if I plug in 1 in here, it gives me the height after 1 second. F of 2 will give me the height after 2 seconds, and so on and so forth. So graphically here, what's happening? My input is time. Input goes on the horizontal axis. And my output is the height, go on the vertical axis, which is the function f of t. I'm going to graph it. All right, we know this is a parabola because it's quadratic. It's a parabola concave down because a is negative. So it's going to go something like that. So that's really the graph of the height. So at every moment, the output is telling me the height. So the question is, when does the ball hit the ground? When does the ball hit the ground? How should I answer the question? What do I need to find? Quickly. Okay. When can I find? When does the ball hit the ground? Anybody? So you take up, it reaches maximum height, then it goes down. When the output is 0, exactly. The ball hits the ground when f of t is equal to 0. Okay, so we're going to set f of t equals 0 and solve for t. So the ball hit the ground right there when the height is equal to 0. So we're going to set f of t equal to 0. So now we're going to set f of t equal to 0. And we're going to solve for t. Now, of course, we're not going to factor this. This is actually, we don't know how to factor it, as simple as that. So the question is, we're going to use the quadratic formula to do that. So my a is minus 16 my B is 50, my C is 200. And B squared minus 4AC, I will compute it, as I said, always at the beginning, because to make the math easy later on. It's 50 squared minus 4 times minus 16 times 200. And I plug in those into a calculator. So I'm gonna get 50 squared, 4 times 16 times 200. So I'm getting 115,300. Okay. All right. So in this problem, we are going to find the time. So let's find t. So since quadratic, there are two values of t that make this 0. So let us find them. The first one is minus b plus the square root divided by 2a. This is equal to minus b, it means minus 50, plus the square root of that divided by 2a. This number. Now this is because it's really, this is a really complicated number. I'm just gonna input this whole thing into a calculator and estimate the time. So in this problem, I don't want you to simplify. I just want you to use the calculator to find the time. So let's see what we get. So it's minus 50 plus the square root of 1,5, I'll do it in front of you, 300, that's the numerator. I need to divide it by minus 32. I'm getting minus 2.3. But t is time. So minus 2.3, that's a negative number, but we cannot to reject because t represents time in this case, because t is positive, t is time. So I need to find the other one. The other one is going to be minus b minus the square root over 2a. It means minus 50 minus the square root divided by 2 times minus 16. Again, I have to evaluate this, unless some of you did it already, can help me with the answer. So again, I did the same thing, minus 50 minus the square root. I got the answer, and I divided this by the denominator, which is minus 32. And I get 5.42. And second. It means after 5.42 seconds, the ball will hit the ground again. So the ball goes up, and then it's going to hit the ground again. And it hits it after 5 seconds, a little bit over 5 seconds.
Could you go over how you put it in the calculator again? I'm not getting the same answer you did.
Okay, that's why I want you to do it with me. That's great. Okay, my numerator is, watch, minus 50. You see it?
Yeah.
Plus the square root of 15300. Are you with me so far?
Yeah.
That's my numerator. I enter it. And this whole numerator, I want to divide it by 2a, which is minus 32.
Oh, okay. I was doing it with the -2 altogether. Like the negative, I was dividing it with the -32. I wasn't doing it separate.
Yeah. If you it's wrong. Because in your case, you're not dividing the whole numerator. You're dividing only the square root by 32. You're not dividing the 50.
I see it now.
Okay, end of the problem. All right, so that's how we find it. Now, the other question that I'm not going to do because I've done it before, but I will suppose I ask you when does the ball or the object reach its highest value? How would we do that? So this object, you throw it, it reaches maximum and it comes back. So if I'm going to ask you, when does it hit its maximum value? How do we do that? When does the ball, when? It's not the problem number 15. When does the ball or the object reach its maximum height? Quickly, is this an easy or a hard question? Back to
We
you.
would find the vertex.
Exactly, we just find the vertex. And we've done this several times, okay? Just find the vertex. Okay, and that's it. We know when and what is the maximum height. The time will give me when, and when I plug in into the function, so whatever time I get here, which is going to be minus b over 2a, so this is going to be minus 50 over 2 times minus 16. I mean, that's as simple as that, which is basically 50 over 32, which is almost, just to have a picture in our mind, 1.5. So a little bit, after 1.56 seconds, that's when it hits its maximum value. And the maximum height, you just have to find the value at 1.56. Okay. And those problems are one of the best applications to quadratic. Those problem is a typical physics problem. The formula comes from physics. And any of you who has taken physics or will take physics, you will encounter those formulas a lot because they represent any object. You throw it up, it comes down. It gives you the formula for the height above ground. Okay. From here, we're going to move to chapter 3, basically exponential function. So we studied linear, we studied quadratic, and we're going to move to what's called exponential. But to be ready for that, I have to talk a little bit about exponent. Okay, so to be able to talk about exponential, I'm going to do a very quick review, and I mean a review of exponent. For some, it's a review. For some, I think they have to learn it with me. All right, so review of exponent. Before I do review exponent, just for my own peace of mind, because I want to a little bit remind you the nth root. And I know a lot of you know it, but I have to remind you a little bit the nth root. What's the idea of the nth root? So first of all, what's the square root of a? The definition. The square root is just the number, the positive number, when raised to the power 2 gives a back. A back. Okay, that's the definition. It's the positive number when raised to the power 2 gives a back. So square root of 4 equal to 2 because 2 is the number. When you square it, you get equal to 4. Okay. Now, what's the cubic root of a? What's the cubic root? The cubic root is again the number when raised to the power 3 gives a back. Three gives a back. Okay, so for example, the cubic root of a is basically the number, such that when you take this number and you raise it to the power 3, you get a back. So typical example, what's the cubic root of minus 8? It means what's the number? When you raise it to the power 3, you get minus 8 very quickly. Very quickly. What's the
Negative 2.
No. Why not 2? Why 2 is wrong? Because if I take 2 to the power 3,
Negative.
it has to be negative. Because 2 to the power 3 is just give me 8. And I want negative 8. So this is going to be equal to negative 2. Okay. Now let us note one thing. Under the cubic root, I can have a negative number because when I take a negative number to the power 3, I can get something negative. For the square root, I cannot have a negative number because there is no number. When you square it, you get 4. Whatever the number is, when you square it, you're going to get a positive number. So we can have cubic root of negative, but we cannot have the square root of a negative number. So in general now, what's the nth root of A? Nth root, that's in n here. So that's called the nth root of A. Is the number when raised to the power n, you get A back. Power n, we get A back, gives A. Okay. So the nth root of A is this number such that when you take it, raised to the power n, you get A back. And that's what we call the nth root of A. So for example, what's the 4th root of 16? No, 16. I don't want 16. I want 81. What does this mean? It means what's the number? When you multiply it by itself 4 times, you get 81. What's a good candidate for that? That's really what this answer is.
3.
Exactly 3. Because 3 times 3, 9, times 3, 27, times 3 is 81. So this should be equal to 3. So that's really what the force is. What's the number? You take it to the power 4, you get that. So what's the 5th? So of course, as you realize, I have to give you easy numbers, otherwise, because you can't. Again, what's the 5th root of 32? What number? You multiply it by itself 5 times, you get 32. Anybody on the top of their head? It's actually 2. Because if you take 2, if you take my calculator, and if I take 2 to the power 5, I get, honest to goodness, 32. So this is equal to 30. So that's what the 5th root is. Now, properties of the roots, of the nth root. What do I mean by properties? Properties, I mean the following. If you take the nth root of A multiplied by B, so here there is a multiplication, and that's very important. You can split the nth root. So when you have multiplication, you can split them. You can also split them when you have a fraction. So this, you can split that over this. So these are the products. We can split them, but they have to be a product here, then we can split. However, what fails? What's not true? What's not true is the following. If you have a sum, that's crucial. If you have a sum under the root, whatever the root is, this cannot be broken. So we can break the product. We cannot break the sum. So let me show you why. Suppose I take the easy one, square root of 9 plus 16. This is not that. We cannot break it, and let's see why. 9 plus 16 is 25. This is equal to 5. The square root of 9 is 3 plus 4, definitely different from each other. So it's very important that if you have a sum under the root, we can't split it. We can split product, but we cannot split a sum. Okay. So now, before I move on to exponent, let me ask you a very simple question. Okay, my question is, I want you to simplify so no roots remain. Okay, so I'm going to give you something with a square root or cubic root, and I don't want the root to remain. What's the cubic root of A3? Quickly, it's a simple question.
A.
A. Simply because A to the power 3 is A to the power 3, pure and simple. All right, what's the cubic root of A6?
A squared.
A squared because. Correct,
Oh.
because.
So for the same reason above.
Okay, so same reason above, or one way you
Oh,
can.
I was muted for my explanation. I'm sorry.
Oh,
I didn't get to finish, but for the same reason above, because there's 2 times the amount of the exponent
right,
under the.
2 times, exactly. A6 is basically, it's how many A's? 6 of them. So this is 3 of them, and this is 3 of them. So 3 A's times 3 A's give me basically A to the power 6. Now, if you can break this and break that, you're gonna get A squared. Okay, so simple ideas to deal with the square root. Now, I'm gonna move from here to exponent. All right, so exponent.
Could you go back for just 1 second, please?
Of course I can.
Okay, thank you.
Okay, all right. Now exponent. All right. First, suppose n for me is a positive integer. So it means 1, 2, 3 for now. First, a to anything to the power 0 is 1. Anything to the power 0 is 1. Now, if you take a to the power n, of course, you know what this is. It means you take a, you multiply it by itself n times. So for example, 2 to the power 4 is 2 times 2 times 2 times 2. All right, so that's the simple ideas. Now, negative exponent. Negative exponent. All right? What does it mean to say a to the power minus n? What does this mean? So something like if you see 2 to a negative power, what does this mean? What's the definition of that? Anybody? What does 2 to the minus 3 means? Anybody has any recollection? Okay, this means 1 over a to the power n. So a to the minus n, if you have a negative exponent, it's 1 over a to the n. So the minus n, a, this one go to the denominator and become a to the n. So let us immediately practice this. So for example, what is 2? Somebody you see in a book, 2 to the minus 3. This is equal to what? So according to that, 2 is the a, n is the 3, and that's a minus. It means 1 over 2 to the power 3, or 1 over 8 if you want. Okay, take another example. What is 4 to the minus 5 mean? Back to you. Please put it on chat. What is 4 to the negative 5 mean? What does this minus mean? According to my definition. Anybody? You guys are way too quiet today. No, it's 1 over 4 to the 5. If you have a negative 1, it means 1 over 4 to the 5, which is, if you want, I don't even know what 4 to the 5 is, but I don't think I care, but it means 1 over 4 to the 5. That's what a negative exponent means. Okay, now what is something simple? 8 to the -1. What does this mean? Please on chat quickly. What does it mean to you? You have a negative number here. What does it mean to you quickly? It's 1 over 8 to the power 1. It means 1 over 8. Okay, so that's what negative exponent means. Now, fractional exponent. Fractional, that's a fractional exponent. Okay, we're gonna see two of them. Okay, sometimes you have a, but the power is something like 1 over n. It's not negative n, it's not -2, it's a fraction, 1 over n. What does this mean? This means the nth root of a. Means the denominator here, this one is the root. So when you have 1 over n, this n is the root. Immediately practice that. So what is 8 to the power a third? What does this mean in terms of root? What does it mean to have a fractional exponent? I mean, we know 8 to the power 3, but what's 8 to the power 3? It means the cubic root of 8. Okay, 1 over n, it means this 3 is the root, the cubic root of 8, which is equal to 2. So that's the cubic root of 8. So let's take another example. Again, simple example. 64, I want 64, no. 32, because I did that, to the power 1/5. What does this mean? I don't want the answers. I want you to rewrite it using the root. What does this mean? It's which root? It's the 5th root of 32. 5th root of 32. That's what it means. So 1 over 5 means the denominator becoming the root. So and now 5th root of 32, we know what it is. It is 2. What I care about now is moving from this fractional exponent to the root exponent. That's the piece I care about right now. Now, the last piece of those exponents, which is a little bit also hard, but that's the last one. The last piece is the following. Again, fractional exponent. Now here we saw a to the 1 over n. Now the last piece is, what if we have a, not 1, m over n, like to the power 2/3, okay? What does this mean? What does this mean? It means the following. The n, the denominator is the root, so that's going to give me the root, that's the number a. And this gives me the power. So it's n roots of a, or those two are the same. You can put the power either outside or you can put it inside. Those two things are exactly the same. So a to the m over n, so this always, the denominator is the root and the numerator is the power. Okay, that's to help you a little bit memorize this. So let us practice this notation a little bit. So for example, if I give you 8 to the power 2/3, okay? And I want you to write this based on this definition in front of you as some kind of a, in terms of a cubic root. So I want you to rewrite it so there is no fractional power. What does this expression mean? And then we evaluate. I don't care about the value for now. I'm going to use this verbatim. What does this mean? the following. The denominator is the root. It's the cubic root of 8 to the power 2. Okay, cubic root of 8 to the power 2. Once I write it this way, that's easy to evaluate. The cubic root of 8 is 2 to the power 2, which is equal to 4. Now, let me make a comment here. If I take the cubic root of 8 squared, it's exactly the same thing as that. That's why I put it both ways, because the cubic root of 8 squared is 8 squared is 8 times 8. And I just told you that we can break up the product. So that's the cubic root of 8 times the cubic root of 8, which is the cubic root of 8 to the power 2. So whether you put the power outside or inside is exactly the same answer. And then when you evaluate, you pick the one which is easier for you to manipulate. So another question along the same line is crucial for us to understand those exponents. I'm going to put something like that, 75 to the power 4/5. I don't want the answer now, but I want you to rewrite this correctly using root. So what will this become? So I want you to rewrite, so no fractional power in here. So it's the 5th root, absolutely, of 75 raised to the power 4. Okay, so that's the 5th root. So the denominator is the root and the numerator is the power of the whole thing. So that's what those fractional exponents are about. So now I want to give you the following practice problem, and it shouldn't take more than 3 minutes with us, right? Just as contrast and compare. I want you to 4 to the minus 2 minus 4 squared. So we want to rewrite each one of them. 4 to the power a half, 4 to the power minus a half. And if I have time, 4 to the power 3/2, for example. Okay, we're gonna rewrite each one of them, at least each one of them. So there will be no power. So we're gonna simplify them. Okay, the first one, 4 to the minus 2 is what? Quickly on chat, very quickly, I want the answers. Okay, it's 1, that's a negative power. It's 1 over 4 squared. Okay, minus 4 to the power 2. There is no relation whatsoever between those two, very different. This is nothing more than minus 4 times minus 4, 16. Okay, so be very careful. 4 to the half is what? In terms of the square. What's 4 to the half? Here, that's a 2. It should be the square root of 4. But we know when there is a square root, we don't put the 2. So this is nothing more than a 2. All right, 4 to the minus a half, that's a little bit tricky. I'll give you a minute because I have it. What's 4 to the minus a half? Right. Whenever you have a minus, don't be scared from it. Since it's a minus, it's going to become 1 over 4 to the half. 1 over 4 to the half. It means 1 over the square root of 4. It means 1/2. Okay. And finally, 4 to the power 3/2. Okay, now I have to use the formula. This is the root, so that's the square root, and this is the power. So it means, because it's a 2, that's the square root of 4 raised to the power 3. It means 2 to the power 3, which is equal do it. Okay. All right, I definitely have to stop here. For next time, the homework I'm assigning, the practice problem I'm assigning are from an old section, like, I don't know, 1 point something. It's not the new section. So I'm going to assign some problems from along the height problem, and I'm going to assign some problem along those which were from the previous section. And I will put online also on the announcement a worksheet or a sheet with all the properties and the definition of the exponent. Please print it and have it always handy when you're dealing with those problems. All right, so the quiz is on. Please get started.